So in this video, we're going to look at double integrals, but we're going to really approach it from a point of view of, first of all, understanding the symbols used in double integration and how they actually are used to calculate the integral. And we'll come to the interpretation and in other words, the applications where volumes are computed and so on a little later. Okay. So first, let's start with what we see when we see a double integral. So when you see a double integral, what you usually see is you see some region R. Okay, you would see something like two integrals here. So you'll see the integration sign twice. You'll see this, some letter here, some capital letter here, could be S or A or R or anything. Then you'll see the function you're integrating, okay, which is usually a function of X and Y. And then you see this D capital A or D capital something. Now, this itself, as it stands, you can't integrate, you can't do anything, in fact. So the first thing to understand is that the first step from here is usually to look at what this R is, because the question will define to you what R is in fact, okay? It'll be given to you. For instance, here, a simple R could be that X is between A and B and Y is between C and D. Now, if that's the case, then one can easily now write down the integral. For instance, you can say AB here and CD here, and your function f of xy, whatever that is, and of course, first it's x and then it's y. So that's simple enough, and now actually this is a practically doable integral, where what I mean by that is you can in fact compute the integral, okay, given a particular fxy. Now, let me demonstrate that with this same example here. If I now choose an f of xy, for instance, with the same range of values, let's keep these values as they are. So a, b, c, d, and let's say we have x squared plus y squared as our function, and we're calculating dx dy. Now the way this works is, first of all, these integrals are called iterated integrals. Iterated, these are referred to as iterated integrals. Okay, now what that effectively means is that the way this works is, you see this part here that you see, this is an inward integral. So there is a sequence to this integration. You must first integrate this inner integral, and then once you've integrated that, then you go to this outer integral. And that's how this is the first iterate, and then there's the outer integral is the second iterate. So the first iterate, as an iterative process, it feeds into the second iterate. Okay, so in other words, in order to do this, the first thing we will do is, you can almost think of the integral AB of x squared plus y squared with respect to dx completely separately from the complete double integral that you see there. Now, if you were to calculate this, of course, which you can easily, it works the following way. Since you are integrating with respect to x, the y is treated as a constant. It's x cubed over 3, and the y squared, simply y squared x, okay? Now, of course, there's no c, since we have, this is a definite integral, and it's a to b. Now, by the way, one other thing to keep in mind, you will rarely ever, I can't think of any situation where a double integral is actually an indefinite double integral. Those are always calculated using some limits, okay? Both integrals will always have limits. So don't expect to see any indefinite integrals when it comes to double or triple integration. Just a small thing to keep in mind. Anyway, so a to b, as you put in these values, so that will become, so that's going to be equal to b cubed minus a cubed over 3 plus, that's y squared as well, sorry about that. So it's going to be y squared, so in other words, b minus a into y squared. Now we will feed this into the integral above that you see, which is c to d, okay, of all of this. So b squared minus a cubed over 3 plus b minus a y squared dy. So as we integrate this now, again, this time we're integrating with respect to y, so basically this will just become b squared. No, not b squared, this is b cubed, pardon me. Okay, Sorry, this is b cubed. Sorry about that. Okay, so it's b cubed minus a cubed over 3 y plus b minus a y cubed over 3. And the range of course, here, the range of values is going to be just, of course, from, where it is, c to d. Okay, so c to d. And you substitute those values in, and what you end up with is the final result, which is b cubed minus a cubed over 3 into d. Okay, and in fact, if you like, you can just cut it short and say d minus c here. Okay, plus b minus a into over 3 into d cubed minus c cubed. So you end up with that result, and you see that, of course, that's basically your final answer. So this is how we calculate the integral. So what I want you to understand from this is what are the mechanics of the actual double integral. So you do the inner integral first, and then you move outwards towards the final integral. Okay, now there's another thing you need to keep in mind, which is when we are doing the double integration, you can encounter, for instance, a situation where you may actually get, here, for instance, you could get a function. So you could get a h1 of x, and this is h2 of x, some two functions of x, and these are numbers a to b. Okay, and then you're calculating the integral fxy, and of course the inner one is dy and the outer one is dx. Now, these integrals, again, let's stick to the mechanics of how things are laid out. Interpretations and what are these limits and how these limits come about, we'll look at that in a separate video, because that requires significant and good understanding of how regions are placed and what areas are being integrated or what volumes are being calculated. So we come to that in a minute, or in a different video. Here, I just want you to understand what you might encounter. So you see here this is a function of x, and this is another function of x. Now, if these are functions of x on the limits, then this, of course, has to be an integration with respect to y, because at the end of the day, x is considered a constant if you're integrating with respect to y. So clearly, these functions h1 and h2 are, as far as y is concerned, they're constants. Now, if I were to have functions of y here, so in other words, I could have this situation, or have these numbers a, b outside, for instance, but instead of h1 of x, I may have g1 of y and g2 of y, okay? And in that case, the inner integral is, of course, with respect to x, and the outer integral is with respect to y. Because remember, when you integrate the f and you substitute in the h1 and the h2 into the result, you're going to end up with a function of x. So this whole thing, okay, will result in a function of x. Okay, so this will result in a function of x. And this here will result in a function of y. So of course, that makes sense. Well, what is left? What are you going to do next? You're going to do the x integration. So therefore, this is a function of x. Here, you're going to integrate with respect to y. So you expect this to be a function of y. Now, what I want you to further understand is that these limits here, the outer integral, these are numbers. Look, when we practically integrate, the double integral is usually there to calculate either a volume or actually, it ends up usually calculating a volume. Sometimes you'll see there's a formula which just helps you calculate surface area. But whatever it is, at the end of the day, all of these things, whether it's a surface area or it's a volume or it's anything else, is a number. It has to be a number at the end, which means that these numbers a and b are usually the constants. So the result should be a constant. That's what you usually expect in any questions to do with double integration. So therefore, when you get limits that are variable, and actual functional limits, or limits that are functions themselves, like the h1x and the h2x, okay, or the g1y and the g2y, then these are always on the inner iterate, okay? These are always the inner integral, okay? They are never the outer integral, because if you did that, you will end up nowhere. because the answer will not be a constant, and in fact you will not be actually computing the integral that you want to eventually get to. Okay, so that's an important thing to keep in mind in terms of sequences. So what I'm trying to do is I'm trying to give you some ideas as to how you make sure that you're proceeding in the right way. There are some checkpoints to just keep in mind.